There is only one perfect solution, but there are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb and welcome to Denial Displays. In this case, what we have here is we have a series of 5 different numbers with black backgrounds. We're going to have a confirm button with a green background, a deny button with a red background, and we're going to have a 3-digit code which we can interact with here, in this case, in a blue background. Now, the code itself that it's set to originally does not matter because all the work that we're going to do is going to be on this manual side. None of this stuff matters in this case. So, let's take a look and see exactly what we need to do and how to solve this module. So this module contains 5 black screens, as we mentioned, a red screen saying deny, and a green screen saying confirm, a blue screen with 3 dials which can be changed. Each of the 5 black displays will show a 1 to 3 digit number anywhere from 0 to 999. Now, each time deny is pressed, one of the display numbers will change. In this case, any one of these will change, and each display can only be changed once. Therefore, deny can only be pressed 5 times. Pressing deny more than 5 times will, of course, result in a strike, as you can see here. Now we're going to use table 1 to confirm whether we need to press confirm or deny. And that's what we're going to do with this little table right here. So now, let's take a look and see how to resolve this module. So pressing deny or confirm when it should be pressed will result in a strike, obviously. The module will deny if the module will function as if the deny was pressed, and you will be required to continue until you reach on the confirm. So in this case, if you happen to press confirm, if you happen to press deny when confirm should have been pressed, it will function as deny as it was changing one of the displays. So keep that in mind. And if confirm needs to be pressed, use table 2 to determine the 3-digit code. We'll get there. We'll cross that bridge when we get there for the table 2 confirmation bit. But first things first, we need to focus on table 1. So, the dials must be set to the correct code when the confirm button is pressed. If the dials are set to the wrong code when confirm is pressed, a strike, of course, will be given. So, what exactly do we do with table 1 denial, and how exactly do we determine what button we're going to be pressing here, whether it be confirm or deny? So the table is based around 5 displays. In this case, all 5 of these numbers that we have here. If a condition applies, we're going to add or subtract the value to the overall total depending on which column it's in. In this case, the left column is always going to be add, the right column is always going to be subtract, and these rows are going to represent the value they're going to either add or subtract. 1, 3, 3 2s, and the rest are going to be 1s. So, let's take a look. So, if a condition applies, of course, we're going to add or subtract to the value to the overall value. The starting value does start off as 0. Keep that in mind. So I'm going to put this as a 0 right now. And multiple conditions may apply, and it's highly likely that they will. Just keep that in mind. And now, cases where they start off with for each, as it says here, these conditions may apply multiple times. And what this means is it's going to be referring to these last 6 conditions that you'll see down at the bottom here. In this case, there is a possibility, these are going to be looking at each individual display rather than the entire module itself. If there happens to be a case that applies to 2 numbers, for example, you're going to apply that value 2 times in this case. So that's going to be the way that works. And it's only for these last 6 conditions that you'll ever see this. Now, if the total number is positive that you get after doing this entire table, you're going to move on to table 2, excuse me. And if it's 0 or negative, you're simply going to press deny and repeat the process until using the new set. And if deny has indeed been pressed 5 times, in this case, what do you do after that point? If the total is still 0 or less, so we're going to take the total of all 5 displays, subtract the absolute value of the total received from the table, and subtract 100 until the number is less than 1,000. So we're going to go through the table again for this last bit right here. We're going to subtract that from the sum of the numbers here, and then we're going to subtract 100 until it is less than 1,000. That's going to be the way that works. Okay, so now let's get into the table, let's figure out exactly what we need to do here, and let's solve this module. So, if it refers to, it's going to have a series of 2 little asterisks. For these first 2 conditions, what it's referring to is, it's referring to if every digit, or if any digit. And digits refer to the individual numbers on the displays. So in this case, 1 is a digit, 1 is a digit, 2 is a digit, 7 is a digit. And the other case is 2 digits that are the same are not considered to be ascending or descending. We'll get into that rule in just a moment. So, if every digit appears exactly once, in this case the range from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, does every digit appear at, exactly once? In this case, that is already a big fat no. We have 4 1s that appear, And I don't even see any 8s, I don't see any 4s, so that's already off the table. So no, it's not true. And if any digit appears in all 5 displays, no, not necessarily. We don't have a 1 down to with a 2, we don't have a 1 with 75. In this case, that doesn't apply. If every display has 3 digits, in this case that's referring to however many total digits each have. The 2 has 1 digit, the 119 has 3 digits, the 13 has 2 digits, and so on and so forth. No, every display does not have 3 digits. If every display has 1 digit, now you might be thinking, yes, technically every display does indeed have 1 digit, but this is referring to exactly 1 digit. It doesn't necessarily say that, but this is only referring to if it has 1 digit by itself. The 2 would count in this case, however, every display is either a 2 or a 3-digit case, so that does not apply. If all 5 displays add up to 1500 or more, just from eyeballing it, no, they don't. However, if all 5 displays add up to 250 or less, in this case, that is indeed true, because if we take a look, 119 plus 13 plus 17 plus 75 plus 2, in this case, that is indeed true, so therefore, we're going to now be subtracting 2 from our total. So minus 2. Now, if there are fewer than 8 digits total, now this is not going to be the exact same case where it's referring to these kind of digits where it's 0 through 9, but rather it's referring to the total count of the amount of digits in each of these numbers added up. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 total digits. It's not fewer than 8, and the other condition is more than 11. It's neither of these. It's 10, so therefore we don't care about that. If there are 3 or more 2-digit displays, that is indeed true. We do have 3 or more 2-digit displays. We've got the 13, we've got the 17, and we've got the 75. Therefore, this is indeed true. We're going to add 1 to this. So we're going to go down up to -1. If there are 3 or more 1-digit displays, well, we already know that for a fact that this is not possible if the first condition applies, so therefore this is not true. And besides, we only have 1, so it doesn't matter. So now, if there's an even number of odd digits, so let's take a look at all the digits we have here, count the amount of odd digits we have. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. That is not an even amount of odd digits. And do we have an odd number of even digits? In this case, we do. We only have this 1 even digit. Therefore, we only have 1 even digit. Therefore, it's odd. So in this case, we're now going to subtract 1 again, giving us back to -2. If there are more even than odd, that's a joke. In this case, the only even digit that appears is the 2, so therefore, if there are more odd than even, then in this case, we're going to now subtract 1. That is going to be a -3 now for us. For each display in the 600s, if it's in the 600 range for these 3-digit ones, in this case, that would apply, and now we're in the for each conditions, so there might be more, that might be 600. For example, if we happen to have 625 or 649, both of those would indeed apply to this. Therefore, we would add 2 instead of just 1 for those conditions. But in this case, that does not happen. And for each display in the 200s, no, we have 1 in the 100s, not the 200s. For each 3-digit display with digits in ascending order. Now, in this case, you might think this is indeed ascending, 119. However, 2 digits that are not the same are not considered to be ascending or descending, so in this case, this is not true. This never happens. And for each digit display with digits in descending order, well, no, because we have the only digit display that we have is 119, which we determined was neither ascending or descending, because of the fact that we have 2 digits that are the same. And finally, for each 2-digit display that is a multiple of 3, we do have that with 75. The 75 is indeed divisible by 3. We can add 1 to this, that gives us -2. So in this case, that is indeed it for that one. 13 is prime, 17 is prime, and 2 obviously is not a 2-digit display. And finally, for each 3-digit display that is a multiple of 5, no, 119 is not a multiple of 5. So therefore, we have reached the end of this table, and now we know for a fact that we have reached the negative sign. If the total is 0 or negative, we're simply going to be pressing deny. And as you can see now, one of the displays just changed for us. So now we have to go through the table again. So let's start at 0 again. Now, a lot of the stuff will not change, but there might be definitely some things that do change. We still have duplicate 1s. That's not going to change. Every display is not 3 digits, nor is every display 1 digit. If all 5 digits add up to 1500 or more, still no, it's not even close yet. However, this rule changes now. if all five displays add up to 2,500 or 250 or less. In this case, we have 594, therefore that's more than 250, so that is not true anymore. If there are fewer than 8 digits in total, no. However, there might be more than 11 digits in total now. In this case, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If there are more than 11, though, it's specifically asking for more than 11. So in this case, there is exactly 11. This rule does not apply. If there are 3 or more 2-digit displays, no longer applies because we just got rid of one of our 2-digit displays. It's not 3 anymore, and there's still not 3 or more 1-digit displays. So no. Now we need to check these two rules again. If there is an even number of odd digits, in this case we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9. It's not an even number of odd digits, therefore this rule does not apply. Otherwise, if there's an odd number of even digits, we have 1, 2. This rule no longer applies because we only have 2, which is therefore an even number. We have an even number of even digits. It's not an odd number. If there are more even than odd, no, there's still more odd than even by a long shot, so that is going to be a -1. That still does not change. For each display in the 600s, we don't have any of those. For each display in the 200s, we still don't have any of those. For each 3-digit display with digits in ascending order. In this case, we have figured out that this one did not apply. This one, however, is not in ascending order. We've got 594, and that's kind of going all over the place. It goes up and then down. It doesn't make sense. So it's neither ascending or descending, so that's the next rule taken care of. For each 2-digit display that is a multiple of 3, we got rid of the one display that was a multiple of 3 for us. Now, for each digit display that is a multiple of 5, no, none of them are. So in this case, we end our total with -1. It's still a negative, so we're going to hit deny again for the second time. This changes now. Ooh, interesting. Okay. So now, let's take a look at our next rule here. So we actually need to check everything if it appears once. There's still 2 1s appearing, so every digit does not appear exactly once. If any digit appears on all 5 displays, no. If every digit has 3 displays, has 3 digits, no, no. We just lessened our total. It's still greater than 250. Fewer than 8 digits in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10, so it's back to 10. Neither of these rules apply. 3 or more 2-digit displays, yes, this applies now. If there are 3 or more 1-digit displays, nope. So we're now currently at a total of 1. Starting over again. If there's an even number of odd digits, let's take a look. 1, 2, 3, 4, 5, 6. That is indeed true. An even number of odd digits does happen here. We've got the 1, 3, 1, 7, and the 5, 9. There we go. If there's an odd number of even digits, let's take a look. We have 1, 2, 3, 4. Still not the case. No. So in this case, we have a total of 2 now. So we're doing pretty good. This might be the case for us. If there are more even than odd, do we have that happen here? We've got 1, 2, 3, 4, 5, 6 for the odd digits. We've got 1, 2, 3, 4 for the even digits. The odd is still greater than even, so we're going to subtract 1 here. Okay. And then for each display in the 600s, no. 200s, no. For each display, 3-digit display, we determined that this was neither ascending or descending. And for each 2-digit display, that is a multiple of 3. 46 is not a multiple of 3, as far as I can tell. 46 divided by 3 is indeed not a multiple of 3. And for each 2-digit display, the only one that we had beforehand was this one, which we agreed was not a multiple of 5. So in this case, what we have here now is we actually have a return of a positive. So this means that we can now hit the confirm button, but we need to set up a code first. So now let's head down to table 2, in this case, the confirmation. If we've reached this point, the total we got from table 1 must have been positive, so keep that in mind. It wants us to take along the total that we got from the previous stage, so we want to make sure that we note this down. In this case, 1. I'm going to zoom in on this, by the way. So now, what we're going to do here is we're going to take the total from table 1, and we're going to add the total number of digits from the 5 displays. Now, this is not referring to the total of 13 plus 17 plus 594. No. What we're going to do is we're going to count up the total number of digits we have. In this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 plus 10 is going to be an 11, and that's going to be our total for this. So then what we're going to do is we're going to take the least significant digit from that total, and this section of the table is this is the section of the table you'll be looking at. So in this case, we're simply just going to take the last digit, which is a 1, and this is going to be the table that we're going to be focusing on here. Now, What we're going to do is look at the value in the first display. In this case, the one up in the first in reading order. That's not a confirm, deny, or code button. And in this case, that's a 13. We're going to take the number of digits in the number shown, which in this case is 2, and this is going to be the subsection of the table you're going to be looking at here. So in this case, table 2, right here. Now, you might be wondering what this equation means. Charlie plus delta divided by 2. You might be wondering what's going on here. Now, the displays are labeled in reading order with A, B, C, D, and E, and any letters found in the table refer to the value shown in that display. In this case, if the solution contains a decimal, you're going to round the solution down, which actually might be the case because we're going to be dividing by 2 here. So first things first, A, B, C, D, and E is going to be referred to in reading order. So we have 13 is A, 46 is B, 17 is C, 594 is D. So these are going to be the two that we're going to be using. So we're going to do 17 plus 594. We're going to divide you by 2. We're going to get 305. Remember, we get a decimal, so we're going to round the solution down, and that leaves us with a total of 305. And that is going to be what we're going to input into our code here. So 305. And now, if there was a solution was negative, we're going to drop the negative sign. If the solution is greater than 999, which it's not, thankfully, we would repeatedly subtract 1000 until it falls into that range. And if the solution was 99 or less, we're simply just going to add zeros to the left of it in order to make it 3 digits long. Now, once we have our code inputted into the module, in this case 305, we're going to hit confirm. And just like that is a solved module. A bit of a lengthier mod if you're not lucky, if you don't get lucky enough. But overall, the solving process of this is not too tricky to do once you understand how all the rules work. Because some of the wording is a bit particular. Just make sure that you understand how the wording works and you will be fine. Now, granted, I will admit I'm not going to try and re-roll for a 5 case because that just seems like a nightmare where you have to reset 5 times and still get 0. So it is quite rare for that to happen. And I think for most experiences that I've tried with this module, you will get the confirmation, although I could totally be wrong here. So let's take a look at one final example here and let's close it out. All right, let's see what we get here. Okay, bit of a different number here, series of different numbers.
There is only one perfect solution, but there are clues that will try to trick our team.
So let's take a look. So if every digit appears exactly once, well, 7s appear twice, so no. If any digit appears in all 5 displays, well, no. Then we've got a series of 1-digit displays, several of them are different, so therefore no. If every digit has 3 digits, no. If every digit has 1 digit, no. If all 5 displays add up to more than 1500, we do not have enough 3-digit displays to even get that close. However, it is not 250 or less. We have 634. If there are fewer than 8 digits in total, we've got 1, 2, 3, 4, 5, 6, 7, 8. It's exactly 8. It needs to be fewer than 8. Not the same. And is not more than 11 digits. If there are 3 or more 2-digit displays, no. If there are 3 or more 1-digit displays, yes. We've got the 7, we've got the 7, we've got the 5. In this case, that's going to be subtracting 1. If there is an even number of odd digits, let's take a look. We've got 1, 2, 3, 4, 5, 6. That is indeed true. That's going to bring us up to a 0. Let's check the even digits. We've got 1, 2. It's not an odd number of even digits, so therefore this will not apply. If there are more even than odd digits, in this case, that is false. There are definitely more odd than even, so it's going to go back down to -1. For each display in the 600s, yes, we do have one that is in the 600s, so in this case, this is going to apply. We're going to add this once, only one time, because that's the only display that applies, so that's going to be a 0. And we do not have any in the 200s. For each 3-digit display with these digits in ascending order, well, this 3-digit display is neither in ascending or descending. It's 634, it goes down and then up, so in this case, neither. And for each 2-digit display that is a multiple of 3, 33 is a multiple of 3, that is good, so we get a 1 for this, and for each 3-digit display that is a multiple of 5, the 3-digit display, 634, is not a multiple of 5, it needs to end with a 5 or a 0. So in this case, we actually end on a positive note again, we get really, really lucky this time. So now, let's go to table 2, and let's confirm our numbers here. So we're going to take the 1 that we got from the previous stage, in this case the total, and now what we're going to do is we're going to add the total digits from all 5 displays here. 1, 2, 3, 4, 5, 6, 7, 8. 1 plus 8 is going to be a 9, and we're going to take a look at table 9. The first display that we had here is going to have 1 digit in it, so that's going to be a 1 digit. And this one's a very simple case. It's going to be Charlie x Bravo. So in this case, we're going to simply multiply the third and the second position together. So 7 times 634, in this case, Bravo and Charlie. And that's going to give us a total of 4,438. Now, in this case, what we're going to do is we're going to repeatedly subtract 1,000 because it is greater than 999. So minus 1,000, modulo 1,000. And in this case, that is going to give us a total of 438. We're going to input that into our code here. 438. Confirm. And just like that is a solve module. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.